So, I think the best way to kind of understand these is to dive in. So let's have a look at the theory from the textbook. The Bernoulli trial is an experiment with two outcomes. You can either have a success or a failure. In that worksheet we had, the success was rolling a 6, so the probability of that was 1/6, and the probability is P. So the probability of success is P, and that's a fraction. And the probability of failure, so rolling anything other than a 6, fail, equals, we call that Q, and that's always the opposite, because there's only ever success or failure. It's the complement of P, so it's 1 minus P. And then a binomial probability is doing this several times, like rolling the dice 5 times, or flipping a coin 7 times. Like, it's when you have this trial and you're doing it over and over again. Because once we do that, we can start not necessarily considering the individual trials, we kind of consider them all as a group. And we have this formula, very useful, very good, make sure you write it down, to calculate the probability of getting a certain number of successes. Now, in some things they'll call this R. Textbook uses X, we'll use X. So this is like, so we've got N trials, X successes. So for example, rolling a 6, rolling a dice 10 times, the probability of getting 7 6s is, well, we've got 10 trials. We want 7 6s. The probability of getting a 6 is 1/6, and we want 7 of them. And for all the other options, it must have been 5 6s, the probability for those, and we're getting 3 of those. And that's a calculated job after that. All your probabilities should add up to a 1. Yes, it's a probability. And in particular, if it's half-half, then we've got an easier formula. I wouldn't even bother memorising this. I would always just go straight to this one. This one's your nice, good, chuck it in a formula and forget it formula. Okay, so best way to put this into practice is to actually do it. So for 1A, we know the probability of getting a female child is a half. If you have 3 boys, it doesn't give you, like, the probability doesn't change for the next one, you know. And this question's assuming that there's only 2 sexes. Give your answers as fractions in simplest form. So 5 boys, 5 children, so N equals 5. P is going to be a half because it's probability of getting a girl. Q is also going to be a half because it's 1 minus P. I should have done those the other way around. Okay. So the probability X equals 5, so 5 boys, it's 5C5 times 1/2 to the 5 times 1/2 to the 0. 5C5, well, anything C itself is 1, as you'll remember, times 1 on 2 to the 5. So that's 1 on 32. So 1B, the probability, there are 2 girls and 4 boys. So we're going to call X getting a boy. So we're looking at the probability of getting 3 boys. And if you don't get a boy, you must get a girl. So we're just considering 3 boys. Well, that's going to be, we're doing 5 children. We're finding the probability of getting 3 boys. The probability of getting a boy is a half. And the probability of not getting a boy is 2. Still a half. 5C3. I always forget these. I'm going to have to do my Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4. I mean, you could have put it in your calculator. I did not bring one. 10, 10, 5, 1. So 5C0, 5C1, 5C2, 5C3 is 10. Let me get rid of that highlighting. That must have been confusing for you. So we've got 10 times 1 on 2 to the 3 times 1 on 2 squared. So we've got 10 times 1 on 8 times 1 on 4. So that's 10 on 32. So that's 5/16. Okay, now for 1C, the 4 boys and 1 girl. So this time, N is still 5, P is still a half, Q is still a half, 4 boys and 1 girl, so X equals 4. So the probability of getting 4 boys is 5C4, 1 half to the 4, 1 half to the 1. 5C4 is 5 times 1 on 16, 1 on 2, so that gives us 5 on 32. Okay, finally 1D. At least one will be a girl. So I would like to remind you that Px is greater than or equal to 1. Having at least one be a girl is the opposite, is the complement, the opposite of Px equals 0, where X is getting a girl. So, having at least one girl is the opposite of having 0 girls. It's going to be much easier to calculate the probability of having 0 and then minusing that from 1 than it is to calculate the probability of getting 1 girl, 2 girls, 3 girls, 4 girls, 5 girls, and then adding them all together. So, probability X equals 0 is 5C0, 1 half to the 0, 1 half to the 5. So 5C0 is 1, 1 on 32. So the probability 1 minus 1 on 32, which is 31/32s.